Swayam Prabha. Digital India. Educated India.
Okay, the lecture today is on duration estimation, and the objectives are to look at the methods by which we estimate activity duration, different examples of parametric methods which we will use for duration estimation, and in the end we will have a discussion on applicability of different methods. So we have covered quite a few topics so far, and all of these things, like especially when we did bar charts, we had to use duration. And we are now going to see what is the method by which we can actually calculate the duration of these activities. So if you look at why do we need duration, any suggestions? Why do we actually need duration of activities?
To calculate the whole duration of the project.
Yes, so we actually come on a top down approach. You remember the work breakdown structure has leaves, at those leaves are there activities, and only if we calculate duration of these activities can we calculate project duration. That is the approach we are taking. Any other reason?
Your planning will be based on the durations of each of the activities to track the progress, for example.
Right. So what we talk about is estimating intermediate milestones. Okay, so it's not, we are not just interested in project duration, we are also interested in the detailed milestones of progress. So we need it for estimating milestones.
And finding out the labors,
right.
resources if you want when to get
allocation.
Exactly. So only if we know duration at the activity level will we be able to control the project from the resource perspective also. So if we know when to mobilize resources, when to demobilize, what kind of equipment are required at what stage, how much material should I order, all these things are also can be planned only if we know detailed activity level durations. Now if you go back to the PMI, which is a standard for project management, they have a section on activity duration estimating, and as per the PMI organization you have inputs, you have tools and techniques, and you have outputs. And if you look at, I am not going to spend a lot of time on this, but just to give you a list of the different inputs which constitute requirements for calculating duration. So you can see enterprise, environmental factors, organizational process assets. So these have to do with the company. What are your processes, what are the different tools and techniques you have in the company itself, to do this. Then as you come more detailed, project scope statement. What is the scope of your project? Activity list, activity attributes, activity resource requirements, resource calendars, the project management plan. Okay, so I am just covering this to give you a broad idea of the various aspects that go into estimating duration. We will only look at a subset of this as we go ahead, and then when you get into the tools and techniques, you have really a fairly wide range of tools. So you have expert judgment, you have analogous estimating. So expert judgment means that basically it's heuristic. There isn't a calculation I can do. I ask somebody who has done this before, there isn't data, and we get his judgment on it. Analogous estimating is there is some data available plus expertise. Parametric estimating is what we are going to cover most of this class, and that is typical calculations based on basic parameters. We will get to that. There is 3-point estimate, which we have seen PERT kind of applications. We will cover that also briefly. There is reserve analysis as PMI defines it, which is the buffer you give to a project duration. Okay, so some of these, like reserve analysis, is not very well documented, but I have put it there so that you are aware that these techniques exist. And when you get to the outputs, you have obviously activity duration estimates and activity attributes such as resources and other things which are required. Now what we are going to cover, like I said, for most of this class is parametric estimating, and I want to, and this is probably the most scientific way, but it has its limitations. Let us get into a little more detail. So take a simple example. You can see there is a car there, and it is supposed to do a track, and the total distance of the track is 300 kilometers, and I am putting this in terms of duration, right. So here also duration is a issue. I am drawing an analogy with something which is very much more in physics, and we can build on that as we go. what do I need to determine the duration? Okay, so I am giving you speed alternatives. Okay, and I only want the duration. I am not looking at the cost. I only want the duration. So yes, I have my distance, I have my speed. For each of the speeds you can easily calculate it, right? Whatever the time, and you just mentioned a very key word, average speed. Okay, so if we are assuming that all of this speeds, when we take the speed we are assuming it's average speed, it's certainly not constant speed. Okay, but through this process there has been lots of during at the curves especially, that speed will be much less, straight section speed will be much more, and we need really some way to measure average speed. And in this example it's not that difficult to measure because we have very good tools to be able to clock the speed at every time period, and at the end of the circuit we can say what average speed is. But coming back, what actually influences speed? We know it's not going to be constant, so what actually influences it?
The technology of the engine and the motors.
Is that all? I mean, I can that.
If it's a straight road, then it's a more.
The track influences speed. What else?
Driver.
So certainly the track.
Driver also.
Driver.
Driver influences. Okay, the driver, track. Anything else?
The environmental factors like
Yes.
rain or the
Right.
speed
Right.
of the wind.
So, yeah. Environmental factors, wet track versus dry track. Anything else during a race?
The
Other opponents.
Yes, the other drivers around you will also influence speed. So it's very dynamic. Okay, so yes, if I knew the track and I knew wet or dry conditions, I can still estimate speed for the point. But now when I bring in other factors, like there are others who are going to be around me, someone's trying to overtake me, someone's in front of me, someone's behind me, all of these also influence speed. So it's very difficult to predict speed at a given state. But again, this whole concept of average speed might be easier to estimate, and if we have an estimate of average speed, only then we can determine the duration. Okay, so now taking this analogy to a construction context, here is an activity, it's a masonry activity, total quantity of work is say 300 square meters of block work. What would be the time required to complete that? How would I estimate? What do I need to estimate the time?
Number of man hours.
Number of man hours is
Rate
a,
of laying.
yeah, so I need, it's equivalent to my speed, there is something here, it's my rate, it's again a speed, the speed with which I am laying bricks. Okay, so if we go into this, so I am calling it production rate. Okay, the what do you call, the units are nearly this, very similar. So I have 10 square meters a day, 20 square meters or 30 square meters, and if I am given this kind of data, what is my how many days?
30, 15 and 10.
Okay, that's very straightforward. Okay, very straight. Now where do you think the challenge is?
He cannot work the entire day.
Okay, you cannot work an entire day, but I have
That is
factored
not
that
the-
in. When I take a day, we will see. I mean that's when I say entire day, what is a day? Is it 24 hours? Is it 10 hours? Is it 12 hours? Is it 8 hours? That has to be defined. And in this case, let us say when we say day, I have defined that.
And we are assuming you work on all days continuously at a stretch, and the weekends are
So I don't have a calendar here. We have, but when I am saying 30 days, it means 30 working days.
Again, rate need not be constant.
Rate need not be constant. Okay, so what does 10 square meter a day mean?
Average skill of a labor.
Is
in
it not just skill, it's
Productivity
average
rate.
output for that crew or for that person over the day, just over the day. I mean, it means in the morning he might be slow, afternoon he might be faster, evening he might be slow, we don't know, but we are saying, and it's not just at the end of one day. The average of productivity or the average output is so many square meter per day. I am using the word productivity, we will come to that a little bit later. So, same questions as in speed, certainly the production rate is not constant. Now, we can have a lot of things that affect the production rate, and we will get into that. And we look at where does what are the things that affect production rate?
Human behavior, you get weary through
Okay, so fatigue.
fatigue.
Environmental
If I
conditions.
can go to the board, I think I should write these down. Okay, so one is fatigue.
The organization of tools and work, if it's properly organized.
Okay, organization of work.
His experience.
Okay, experience
Environmental conditions.
and skill. Environment, I'm putting environment, weather,
Mental conditions.
okay, what,
Psychological.
mental and physical conditions, okay.
Availability of resources.
Yes. Yeah, very important, okay, because if labor might be there, work phase might be there, but if the brick is not there, or mortar is not there, or the something to level my wall is not there, whether it's a plumber or level or whatever, then again the worker is idle.
Different parts of the day, like post lunch, before lunch. Like
Yes, so might be we can call it environmental factors, we can call it mental and physical condition,
Can it also depend on the arrangement of bricks? You have the different types of walls.
organization of work, okay. So we can go on, there are certainly many more factors that would come in, but what we are basically trying to highlight here is that there are a series of factors which actually affect production, and given an average, so when I am getting into a new job and I have to estimate what is production of my crew on the job, it is not that easy a task. There are so many factors which influence production, and let us get now one thing we have not actually, because being masonry we have not discussed is what are the work factors, what are the materials. So if I use block work versus bricks, what is my production? If I am working at the height versus ground level, what is my production? So so the point I am trying to make here is there is just a number of factors which influence, which make some of this kind of estimating a challenge. Yeah.
So in this, the number of factors actually, fatigue to mental and physical conditions are related to a person or a crew.
Right.
But availability of resources related to a project that has to be provided by the company.
Right.
So there is a demarcation between, a crew, his production rate, and a company-based production rate.
Yeah, but ultimately all of it affects what?
Productivity of the labor.
Output.
Productivity of the labor. It is all reflected finally in the labor productivity.
Okay, it will be.
Okay, the reasons might be different, and we are not seeing much equipment usage here. Another thing is equipment maintenance and equipment breakdown. If my equipment breaks down, what happens? It's again corporate level policy and maintenance routines and things like that, but it's again affects the crew. Okay, so actually productivity measurement and improvement in construction is a whole area on its own, and we can take any of these factors and go into root causes and how to eliminate and things like that. But as far as the context of this lecture is, we have to understand that this is the base on which our estimate is built, and if this, unless we can actually understand this, be able to estimate what is the influence of this, we will really not be able to come out with a good duration estimate. Okay.